Hello dear participants of the conference. I would like to present you results of our research on the topic of selection of face detection and recognition algorithms for the e-learning system. Computer-based knowledge testing is increasingly used as a form of monitoring students' performance. The introduction of verse testing and later computer-based testing into the educational process became a purposeful step on the way to eliminating subjectivism in the assessment of the student's cognitive activity. Forms of student knowledge assessment in the form of tests have proven themselves as one of the most promising means of increasing the effectiveness of quality management of the educational process, despite the presence of both supporters and opponents of the knowledge testing. Ratios between supporters and opponents is in significant correlation to the quality indicators of the test material and implemented algorithms of knowledge testing. But there is another side of the issue which opponents of testing use as an argument in their favor. It is the emergence of the new opportunities for unfair attitude towards passing a knowledge test, especially in the conditions of distance learning, when the test takers are dispersed in space and are out of examiner's visual control. This requires additional tools and measures for monitoring and verifying the progress of testing process, which would provide confirmation of integrity for the testing for each participant. The most common abuse is the unauthorized use of internet resources or electronic resources in another operating system or browser and handy tools like books, notes, mobile devices, as well as the replacement for a test person. Effective solution to these problems can be development and use of means for activity monitoring using a camera, photo fixation, and face recognition during a test. Face detection, which is a variation of general object detection problem, can be defined as determining whether a given image contains a face, and if it does, finding the location of each face. Nowadays, there are several dozens of computer-based face detection and recognition methods. However, these methods do not provide 100% reliability of identification, and at the same time have limitations in recognition performance. Most of the early algorithms before 2012 could not provide sufficient performance and accuracy due to high variability of images. Among the main challenges and problems of recognition are better two-intense illumination, facial expressions variability, angle of the face towards the camera, face overlap with objects like medical mask or hair, too large distance to the camera. Despite the fact that today there is a great variety of methods, the general structure of face detection and recognition process can be distinguished. At the first stage, detection and locating finding coordinates of the face on the image is performed. The result of detection and locating are the found coordinates of the faces and its dimensions. At the stage of determining the basic parameters, the face image is aligned and normalized geometrically and by brightness. The face is encoded into a set of basic parameters formed by a parametric vector. After that, the direct recognition takes place, a comparison of calculated parametric vectors with identified ones located in the database of identified persons. The main difference between all the considered algorithms will be the face detection mechanism itself and the mechanism for calculating the basic parameters, translating the face into a parametric vector. The most common facial recognition algorithms available today include principal component analysis, Viola-Jones algorithm, histogram of oriented gradients algorithm and its combination with the support vector machine classifier, deep convolutional neural networks. Let's consider the most promising of the listed methods of detecting and recognizing faces in images, analyze their advantages and disadvantages, and choose the most optimal one for our project. The requirements for algorithms for these projects are accuracy of identification more than 95%, recognition speed no more than 1 second on a modern CPU. Principal component analysis. This algorithm has low requirements for computing power, is very fast, but it is very sensible to lighting, facial expression, facial angle, and other conditions. It has strict requirements for image quality compared to other algorithms, and it has low recognition accuracy, usually not higher than 80%. Viola-Jones algorithm has high speed of operation, up to several tens of milliseconds on modern CPUs, has low probability of false phase detection, has slightly higher accuracy than principal component analysis. Accuracy of this algorithm can reach values up to 90%. Histogram of oriented gradients algorithm in combination with support vector machine classifier has much higher accuracy than previously discussed methods, has more stable recognition than Viola-Jones method, has good operating speed, less than a second on modern CPUs, but it is sensitive to the angle of the face. It requires a frontal view of the face. This algorithm satisfies the set requirements, previously set requirements. It has a fairly high accuracy with still sufficient speed and can be used in this system. Deep convolutional neural networks. With this method, very high recognition accuracy can be achieved, more than 99%. Another advantage of this method is resistance to variability of data input noise, like angle of the face, lighting, shadows, different objects overlapping face, etc. Disadvantage of this method is high computational complexity. Usually it requires graphical processor resources to run fast. Considering all of the above, to improve the quality of the system under development, it may be relevant to create hybrid methods that use the advantages and disadvantages of several considered algorithms, thus combining the faster Hawk plus SVM method and the slower but more accurate convolutional neural network method for cases when the first one does not work satisfactorily will allow to create an effective detector. Considering that it is the type of convolutional neural network, residual neural networks ResNet, that have overcome the human level of image classification and also dominated ImageNet competitions for several years in a row and demonstrate high recognition accuracy at sufficient speed, it is reasonable to implement the recognition stage in this solution using ResNet. Further research is continued. That's all for this. Thank you for your attention.